Alright guys, here is your last chemistry lesson of the whole year. Okay. Which will be kind of fun because it kind of encompasses a little bit of the main ideas that we've talked about throughout the whole year, and which is really important, especially in chemistry, is how to write actual equations, especially knowing the type of reactions that go on in the solution that you're only concerned about. But after this, you do have one assignment related to net ionic equations. You'll have a concentration assignment again, so you guys really get concentration, hammer that down. Then you'll have another net ionic equation, so you have two assignments related to this lesson, and then you'll have the review and the test. So the test will really only cover this concept, net ionic equations, and concentration again. And like I said before, okay, if you forgot how to write equations, look back at the other video I created or look back at your notes, okay, because I'm going to assume that all of you do remember, hopefully do remember, or look back. If not, this will be a lot harder, so you need to take a time and to actually go back and do that. But when we talk about net ionic equations, there's some vocabulary and terms that we have to cover first. Okay. One is first a precipitation reaction. Okay. Remember when we talked about our solubility rules? Okay, this is where they came into place, where we figured out if a solid or a precipitate forms when we mix two things together, right? So like if we had two aqueous things that are coming together, okay, so like if we had, let's say, there we go. Let's say we looked at, whoops, that's my eraser, potassium carbonate, which was an aqueous, plus nickel chloride, let's say, nickel 2 chloride in this case. Okay, you would do a double replacement reaction, write the products, which you would get nickel 2 carbonate plus potassium chloride. Okay, and you would balance it, right? So then you would need 2 here and you're done. Okay. So you look at your solubility rules and realize this guy is aqueous and this guy is solid. And this is our solid and precipitate. Which remember, if this happened, if we formed a solid, we had a reaction happening. Okay. Now, before I didn't get too picky when you wrote your phases on your equations, this time you will need to write your phases, okay, because it helps keep everything straight. You need to write the full reaction. So this is the precipitation reaction where you form that solid. Okay. A molecular equation, okay, is basically the same thing. Okay, it's the equation showing the complete neutral formulas for the compounds in the reaction. Okay, so this is a molecular equation. All right. So a molecular equation is basically just a general overall equation you have. And if you have a solid forming, then you can specify it more as a precipitation reaction, right? Remember, we did have some that they were both aqueous, which they were no reactions, okay, which is still a molecular reaction, but it's not a precipitation reaction. The three new things that we're going to cover are a complete ionic equation, which is an equation that shows all the species as they're actually present in the solution. Okay? There's a reason why we call these things aqueous, okay, because it means that they're dissolved in water. So this is not actually how they look in solution, which we'll talk about in a second. Okay, they behave as ions in their actual solution. And then we'll talk about the net ionic equation, which is your final thing that you'll actually get, this thing, which is the equation showing only the species that actually changed in the reaction. So this will tell you the only reactions happening in the solution that you're actually worried about. And then the last thing are spectator ions. And the guys in the net ionic equation are not going to be a spectator ion. So these are the ions that are unchanged. So these are the ones that you basically kind of cancel out on both sides. Now this will be a little bit longer, going through two examples only. So take good notes, use these two examples to make sure you really understand them, and come back to them anytime if you ever do need to. Let's go over an equation. So let's just start with blue again. All right, so let's say we start with, where's my reaction? Here it is. Let's say we mix lead nitrate, lead 2 nitrate solution, okay, with potassium chloride, okay? And I want you to write the net ionic equation if there is one. This is how I would give you a problem on the homework or the test, okay? I will give you the reactants. You have to finish the whole thing, okay? So we first need to actually write our products, okay? So I'll do everything in red as what you will have to do, all right? So you do double placement reaction, right? Oop, I didn't want the 2 there though, because I want you to balance after. Okay, you'll switch lead and potassium around, so one of your products should be lead 2 chloride plus potassium nitrate. Then you would go your solubility rules, remember, to see what's going to be an actual solid, and then you would find out that lead is a solid, and then potassium nitrate is your aqueous. So this molecular equation is a precipitate reaction, which means you have a solid forming. Then you would go through and balance it. I need my 2 here and 2 here, and we're done. Okay. So remember, this is your molecular equation. Okay. Now remember, like I said, these things don't behave like this in the reaction. So what you're going to do now is everything that's aqueous, remember, so this guy, this guy, this guy, do not behave this way in solution. We talked about last chapter how if you have an ionic compound, which these all are, they dissolve in water. And when they dissolve in water, they break up into their ions. So for example, let's look at lead nitrate first, okay? You would break this up into its ions. So based off of this, you know lead is 2+, so you have Pb2+, and then you would break it off, so be plus now, nitrate, NO3-. Okay? So this is how you would show this guy breaking up into his ions. Now you're going to say, what about this 2 here? Okay? This 2 is now where you put it out in front of the guy because you need to balance it. Okay? So this is how lead nitrate actually behaves in a solution of water, where you have lead 2+ ions floating around and NO3- ions floating around. And then the phases for these, like I said, these phases are still going to be aqueous. Okay, so you still have these guys are behaving as an aqueous solution. So then you do the same thing for all the other ones. So potassium chloride breaks up into K+ in an aqueous solution, and Cl- in an aqueous solution. Remember, you had a 2 here, so you had to have 2 here and 2 here. Then you keep going. The solid is the only thing that you do not touch. This still stays PbCl2 because it's a solid. It's not an aqueous thing. It's not dissolved in solution. Only the aqueous compounds you break up. So then again, we need to break up potassium nitrate. So you'll have 2K+ in an aqueous solution plus NO3, 2 of them, I'm sorry, in an aqueous solution minus. Okay. So here now, when you have all these things broken up into their ions, okay, this is what's called a complete ionic reaction. So this equation right here is your complete ionic equation when they're all broken up into their ions, showing how they actually behave in solution. But this isn't the final equation, okay? Like we said before, we're going to have spectator ions, okay? Spectator ions are going to be the things that are the same on both sides. So you have to look now and see what species are the same on both things. So let's go through them. Lead 2+, aqueous. Is there lead 2+ aqueous over here? Nope. Okay, and it has to be the exact same. It will be the exact same. This lead over here doesn't mean it's the same as this because obviously this has a 2+, this has nothing because this is bonded with chlorine. But if you look at nitrogen, 2NO3- aqueous, 2NO3- aqueous, they're the same on both sides, which means we can cancel these guys out. So now we're going to just cross them out. Same thing goes for our potassium. So you see these guys are the same as these guys, so they cancel out. All that's left, that's what you're going to write your final net ionic equation on. So my net ionic equation now is just going to be Pb2 plus in an aqueous solution plus 2Cl minus in an aqueous solution that goes to PbCl2 as a solid. So this is my final net ionic equation, and this is what I would be looking for. But that's what net ionic equations are, okay? Because if you look at, remember, we're not worried about the things in aqueous. So because potassium nitrate didn't precipitate out, didn't form a solid, okay, we're not worried about it. We're only worried about our solid forming. So really the only reaction that we cared about is our lead 2 plus ions interacting with our chlorine ions in solution, creating lead 2 chloride in solution. Because everything else was still just floating around. Didn't do anything. We didn't care about it. We only cared about this. So this would be the reaction that we actually care about in the solution. So again, the first equation we wrote was our molecular / precipitate formula reaction, I'm sorry. The second we wrote was our complete ionic reaction, where we took everything that was aqueous and we broke it up into their ions, okay, except the solid, because that was not an aqueous solution. It was only a solid forming. Then we looked at our spectator ions. We looked at things that were the same on both sides, which was our nitrates and our potassiums. They were the same on both sides, which means they're spectating. Okay, they're not worried about what's going on in the reaction. They're just watching the actual reaction happening. They're not involved in it. So we crossed them out because they weren't involved. They were the same on both sides. And we got our final net ionic reaction. All right. Whew. We will do one more then. We'll see how quickly I can get through this one. I'll do one more for sure, maybe two. We'll see what happens. Ah, there it is. All right, so let's do now. Let's say you want to write the reaction of strontium chloride solution plus lithium phosphate solution. So I want you to write what I would ask the net ionic equation for these two solutions coming together. Okay, so again, okay, gotta write your products. Okay, you look at your solubility rules, double replacement, all that fun stuff. You switch strontium and lithium around, so you should get sorry, strontium 3, PO4 2 as 1. Remember, phosphate's 3 minus, strontium's 2 plus. So you have to switch them to get them to balance when you write the reaction. Plus lithium chloride. Then you got to balance it, right? So you go through and balance it. You'll get a 3 here. And then you'll get, so I'll change that. You'll have 6 of those guys. So you need 6 here. And then you need 2 here, and you're done. Okay. Now look at your solubility rules. Lithium chloride, that's an aqueous guy. While you look at strontium phosphate, well, there's our solid. Okay, so we have a precipitate reaction going now. So now from a molecular equation, we'll break up all the aqueous things into their ions. So you first look at strontium chloride. Like we said, strontium was 2 plus. Remember, we have 3 of them. Plus Cl minus. Remember, Cl breaks up into just Cl minus. Now here's the thing you have to be careful of, okay? Because you're looking at one ion, okay, but there was 2 in this formula, you also have the 3 here. So you'd have a total now of 6 chlorines in the solution. And a way you can always check yourself too, guys, is your charges of these two guys added together still should cancel out. 3 times 2 is 6 plus. 6 times -1 is 6 minus. Add them together to zero out. Okay. If they don't zero out like they do up here in the formula, you have something wrong. Okay. Next, we do the same thing for lithium phosphate. Now you have 6 lithium pluses in aqueous solution floating around, plus 2 phosphates, PO4, 3 minus, floating around. Goes to our solid, which stays the same, strontium phosphate. Don't change your solid, remember, that stays bonded together. Plus our 6 lithium pluses in aqueous solution, plus 6 chlorines in aqueous solution. So now we have our complete ionic reactions. Remember, this is your complete ionic reaction, but not your net ionic reaction, okay, or equation. So now we need to cancel out our spectator ions. So let's go through and see what's our spectator. Strontium? Nope. Chlorine? Yep. So that's our spectator. We'll cancel it out. Lithium? Yep. Cancel it out. Phosphate? Nope. So then we're done. There's our spectator ions canceled out. Now we can look at writing what's left over, which usually is always going to be just 3 guys, remember, left over. So we'll have 3SR2 plus in aqueous solution, plus 2PO4, 3 minus in aqueous solution, gives you your precipitate, your solid that you're worried about when you mix these two solutions together. And here is your net ionic equation. Whew. All right, so how much time are we at right now? Okay, we are at 17 minutes. Okay, I might do one more really quickly with an acid and a base. Okay, to see so something else. And then we'll be done. Okay. Let's do one more real quick with acids and bases. All right, let's say we're going to look at, in this case, let's say we take potassium hydroxide, KOH, in aqueous solution, and mix it with acetic acid, HC2H3O2. Remember, this was acetate, if you remember way back when, CH3COO, okay, minus. So we mix these two together, okay, remember, if this is your polyatomic ion, minus, and this is, potassium is your plus, hydrogen is your plus, they switch spots. Which if I have H now going with OH, okay guys, use your head here, this is not what it becomes. This is water now, H2O, and water is always a liquid. Plus, now you have your other guy forming, potassium acetate, KC2H3O2. Look at your solubility rules. This is aqueous. Now, even though I don't have a solid forming here now, I have water still forming, which means I have something forming in my reaction right now. Okay, well, my pen is not where, there it is. So that means I still have a reaction happening. I can still write a net ionic equation. Okay. It'll still be the same exact steps though. Okay, so your first step is to get to your net ionic, so break up all the aqueous things. Okay, oh, forgot to balance it. It's balanced actually, we're good. So now go through and break up all the aqueous things. So looking at potassium hydroxide first. K plus in aqueous plus OH minus in aqueous plus H plus aqueous plus C2H3O2 minus an aqueous solution goes to treat water the same way as a solid. Don't break it up, so it stays H2O. But then you can break up this guy. K plus an aqueous plus C2H3O2 an aqueous. All right, this is your complete ionic reaction, remember. Okay, so now go through and see what cancels out with a spectator ion. Potassium over on the left side, potassium over here. Boom. Hydroxide, nope. Hydrogen, nope. Acetate ion, yup. So then now you have those separated out, which if you have your final one, okay, now you just have these three guys left over, okay? So you look at it, all I have now is H plus in an aqueous solution plus OH minus and an aqueous forming water, okay? Generally, this is what you will see with acids and bases, okay? Where if you have two acids mixing, two of acid and a base mixing together, you will generally form water. All right, so there are three examples for you guys. Make sure you use them if you ever need to look back, okay? Like I said, there's gonna be 2 assignments on this. This will be the majority of your test, okay? So make sure you know how to first actually write the molecular equation before you go any farther. But again, if you have any questions, just email me.